Hello guys, today we will solving one lead code medium problem, and in this problem we have to just do a level order traversal. So this problem has been asked by many companies, as you can see in my screen that it has been asked in Bloomberg, Amazon, Facebook, Microsoft, and even Google and Uber also. So to so first of all, uh, we will understand the problem. Post that we will code. In this problem, as you can see here, is that we have a tree which has some child nodes. So what we have to do is that we have to print it in a leveled order way. So like uh, so suppose this will be zero level of the tree. This will be first level of the tree, and this will be you can say second level of the tree, and then we have to print it in such a way. So you can see that it's a list of list, and wherein uh, first element of the outer list is itself a list and it has 3 in it. Second element of the outer list is itself a list again and it has 9 and 20, and similarly third element has 15 and 7 in it. So let's first more understand the problem statement. Let me just uh, do it here. You will see what we have to do. Okay, this is the output and this is the input. Okay, let me break it down in this way. So this says that we have an outer list, and inside that outer list we have another list. So that means that we will be requiring something like list of list of, you can say, integer, because this is what we have to return from this method also. Okay, and inside this, so our first list is this, second list is this, and third list is this. So we have 3 lists. So this means that if we discuss only about this particular use case, this first list has you can say around one element. Number of elements, if we number of elements equal to 1. Similarly for this number of elements are 2, and for this number of elements are 2. So that means that uh, whenever we start coding, then first of all we will create this master list that will hold all the result, and post that we will, you can say, iterate at each level, and we will add all the nodes at that level. So that also means that we should be knowing that how many nodes are that at that particular level. Okay, and this problem can be solved in multiple ways. It could be solved by recursively, and it should be solved by using a queue. So in this problem we will be using a queue, and we will be using queue, and we will be doing a BFS over the tree so that we can traverse each and every element in that tree. You can say element or node in that tree. So now I think you have got understanding that what is the problem statement, and I have told you that we will be using queue. So let's go. This is the problem, and we can see constraints also here, like tree can have 0 nodes also. So that makes sense. So let's do it. List of, you can say, integer, and this will be result. This will be holding our overall result. Create new list. Okay, then if result equal to null, or you can say not result, if root equal to null, then we can just return result, because you don't have to do anything. Now this case, if root is not equal to null, so as I said that we will be using a queue, uh, queue of, you can say, renode, queue equal to new linked list, then queue dot add, you can say, root. Okay, we have added the root. So at this point of time, so I am just writing what all elements are there in the queue at this point of time. If we consider only these three, then at this point of time we have three in the queue. Okay, now we will do a BFS. So if queue is empty, we have to do not empty. If queue is not empty, what we have to do? We have to first calculate the size of them. This is important as this will help us to identify how many elements we have to put in each level list. So as you can see that in the first level we have just 3 elements. In the second level we have to just 2 elements. So this will be on the basis of how many elements are there in the tree. And we will also be like, for each and every level we will be creating a list also. So just current level, uh, current level equal to new array list. Okay, and int current level length equal to q dot size. Okay, then so whatever the queue size is, we will iterate over it. Y is less than current level of level length plus plus. Now we have to process this level. So right now 3 is there in the queue and our current level has nothing in it. So this has nothing. So it's like this list is just blank. So what we will do is that first of all we will pop out the node equal to you can say q dot remove. Okay, so right now the queue has 3 initially. Now we have removed it. So at this point of time queue will, so if suppose this array is representing a queue. Okay, uh, yeah, okay, then at this point of time we have 3 in it. Now we have 3 and you can see that in the answer we have to provide 3. Okay, now if we have removed it from the queue, then we also have to process its left sim right child, because in the next level we have to process its next left and right child. So you can see the third left is 9 and third right is 20. Okay, so what we will do is, first of all, as we want the 3 in the result, so let's add it into current level. So add equal to popped not top well. Then if popped not dot left not equal to null, then just add q dot add popped not dot left. Similarly we will do for right also. Okay, just bear with me, I will be explaining all of the code once. once I write. Okay. Yep. Okay, so currently Q has 9 and 20 in it. So we can say that 9 is there and 20 is there. And then we have just till now also processed, like in the current level we have added 3. So this current level has 3 in it. So at this point of time, so let's understand the real logic behind this problem. So right now we have processed uh, one level. So our first level we have processed, wherein we have to provide 3. So first level we have to process. Now how on the basis of this thing we are deciding that we have to create a new list so that we hold this 9 and 20. So that is being done on the basis of this current level length. So initially when we added this root in it, that time q has only one length, so we have written this loop till length of that q, because your current level length is q dot size. Then in the first case, as soon as this thing is done, so we process this one time, just I is initially 0 and current level length is 1. Okay, and we loop through it once. Then whenever I becomes 1, then it is not level less than current level length, then we just skip it. Then at the end here we just add result dot add the level. Now you can see that whenever it is done, then at this point of time we have added 9 and 20, 9 and 20 in the queue. Okay, then it again goes here and it again create a list, and now again it will calculate queue size. So queue size right now is 2. Queue size right now is 2. That means that it will run this for loop 2 times, so that it will process 2 times. So here you can see that with every level we are creating a new list for it, and finally we are adding it the result. Okay. Whenever this is done, so we just have to now return the result. Okay. Yeah, so I think we can run it. Yeah, our test cases has passed, and let's delete this also. The time complexity of this problem is like big of n, where n is the number of nodes in the tree, because we are traversing each node exactly once, and space complexity will be like this. So basically we are creating a list wherein we are saving all our results, so space complexity will also be big of n. So let's submit it. So all test cases are getting passed. I hope you have understood this problem. If there is some doubt, you can comment in the comment section. And also, if you have liked this video, please like and subscribe. Thank you.